Good morning, students. Today's topic of discussion is object-oriented programming in Python. Will anyone tell me what is object-oriented programming? Yeah, students, somebody please come forward and discuss about object-oriented programming. You have studied that in Java. Last semester, one whole full paper you studied object-oriented programming. All right, actually my Bluetooth was not connected. So even if you have spoken, I have not heard it. Object-oriented programming is about having the data and the operations that manipulate data together in one entity, which is called as a class. Class is a user-defined prototype that defines a set of attributes and methods that access the attributes. Students, 1 minute, please give me 1 minute. Sorry about that. We are discussing object oriented programming, where the class is a primary construct. Apparently, it is a collection of data and methods, and it is like a template. Uh, for example, if I say student, when I say student, student is a general entity. Student is not a specific student. When I say student, he, is, uh, he or she can be anyone. A student can be anyone. A LKG student or PG student, UG student, BA student, BSc student, any student. If I create a class student, it has got data and methods that together form the attributes and operations for the entity or the group of objects as a student. Later, when you try to instantiate student, and when you say that John is a student, John is a student. To specify that John is a student, you have to create the object, which is known as object or a class variable or a class instance. A class instance is one particular entity of this entity set. Student is entity set. John is one particular entity. All right. We say that student John is equal to new student. We say student John equal to new student. When we say student John equal to new student, essentially John instance has been created, which is called as an object. This is an object. And what is the uniqueness of this object? This object would have its own values for the attributes or the data members or properties. It has its own value, and operations will are common. What operations would operate on the uh, this data which is defined in this class? If when I say here, when I say that John is an object, John would have the values for the data. What is the data? When you create a student class would have name, roll number, uh, and other details relevant to a student. John would have all specific details. For instance, name equal to John, roll number equal to 1, marks is equal to 90, and date of birth is equals to something, address is equals to something, mobile number is something, means something which belongs to John object. In object-oriented programming, there are important properties. Please tell me, what are the properties of object-oriented programming? We have abstraction, encapsulation, polymorphism. Yeah. Uh, there are various properties or features of object-oriented programming, where you have abstraction. Apparently, class is an abstraction which defines objects and methods. Then you have encapsulation. Uh, Actually, abstraction is relieving only those details which are needed. uh, in a class you can have public, private and protected members based on the access and based on the requirement. Certain properties are uh, shown to everyone. Certain properties are specific to that class and private to it, which are not available for others. And then we have an encapsulation, which is binding of the data and functions together in a class. Then we have inheritance. Inheritance is all about uh, getting the features or the uh, properties of code um, from the existing class, which is called as a superclass. And then we have a polymorphism, where you can have a single function name, and its header is single, whereas its arguments would differ, and based on that it will be invoked. You have a function overloading, function overriding, uh, and such stuff. Class, if we learned class, it is a user defined type. Class variable, it is a variable which is shared by all instances of a class. For instance, a static member in Java. In Java, we have a static function, static class, static data. That is a class variable, because it can be accessed by any instance without any reference to the object. That is a class variable. And please note here that object is not a class variable. Object is different. Object is instance of a class. Class variable is different. Object and instance are different. Class variable means it is within a class. There is a uh, member, and that member is accessed by uh, all without reference to the object. Data member is the data that is defined within the class. Function overloading is a concept where we have common behavior with different types or number of arguments. Instance variable is again the same thing, I guess. Defined within a method, belong to the current instance. Oh, okay. Instance variable means which are in Java point of view, which are not static, which are common general variables. They are known as instance variable, which are not class variables. Instance variables are specific to object. Class variables are not specific to object. They are common to all objects. For instance, classroom. Classroom is not specific to any student. It belongs to all the students. Whereas your bag or your mobile belongs only to you, not to anyone else in the class. So there are specific things that belong only to uh, a object, which is instance, and there are certain things that belong to all the objects. All the objects means class variables. Only to one object is instance variable. Inheritance is transfer of characteristics from one class to another class. Instance is an individual object. Instantiation is the process of creating an object. Method is a function that is defined within the class. Object is a instance of a class. Operator overloading is a concept where operators like plus, minus, operators have been assigned different functionality. Functionality in the sense that functionality would remain same. Plus means it is plus only. It's not about functionality, rather it is about the type of data that it takes. If we say a plus b, this a plus b could be integers, If you want to use a plus operator for objects, let us say this is O1 and O2. O1 and O2 are these objects. Then O1 and O2 could be added. Generally, and by default, plus cannot directly operate on objects. But if you overload the operators, they can operate on objects as well. So that is what, specifying a different type of data with the object is that object overloading. Let us look at the syntax to create class in Python. Creating a class, we have class keyword, class followed by class name. Class keyword or class statement creates a new class definition, and the name of the class follows the keyword class. Finally, it ends with a colon. This one is a class header, which comprises of class, class name, colon. Observe here, there is a string, and this string is called as a documentation string. This string specifies or mentions the functionality of this class, or some kind of comment or documentation of the class. If you want to specify what this class is, like a comment, you can include a documentation string. Immediately after this colon in the next line, followed by class suite. What is class suite? It is components of the class that encompasses class members, including data and functions. In other words, or let me simplify, you have a class keyword followed by class name, colon. If you would, this is optional, documentation string. This is, suppose if I want to say it is a student class within single quotes, followed by statements that belong to this class, that includes data plus functions, which are methods. All right, students, this is the syntax for class, and this one is a simple Python class employee. And you notice here, please notice that uh, this is common base class for all employees within the documentation tag, which is a string, single quotes. It documents the class. M count is equals to 0. This M count is a variable which is equal to 0. We know def. Def is used to define a function. Here we are defining the function init. This init function is the first function which is invoked whenever an object is created. And the convention to create init function is to have double underscore init double underscore. And first parameter is self. Self means, students, please recall this in Java. What is this?
Reference to
Used to
current
refer the
object.
current object, ma'am.
Very good. Reference to the current object. Here, self is the reference to the current object. It is like this. Most of the functions take self as its parameter, uh, just to have a reference to the current object. Name and salary, these are the two arguments. Self dot name equal to name, self dot salary equal to salary. Uh, Initializing name and salary. And then employee dot emp count plus is equals to 1 means a new object has been created. That's why employee count has been incremented. Another function, def display count. This display count function is a function that would print the count. Employee.emp count. What is employee? Employee is the name of the class. Within the class, we have a variable which is emp count that keeps track of the total number of objects created, which in turn um, means the total number of employees created, because one object is equivalent to one employee. This is to display the employee count. Display employee, and what the name of the employee. Self dot name means reference to current object. Salary, this exactly same thing will be printed, and self dot salary. So employee count is a class variable whose value is shared among all the instances. That's why it is accessed with name of the class, not with the object name. If you call any member of the class with object name, it implies that it belongs to that object. Whereas if you call uh, class variables with the class name, it implies that they belong to uh, all the objects which are common. This is the first method. Init, it is a special method. It is like a class constructor or initialization method. Init method is like a constructor and it stands for initialization method. And Python calls init method whenever a new object is created. Like constructor, whenever a new object is created, constructor is invoked. Whenever a new object is created, init is invoked in Python. And class methods like normal functions, with the exceptions that the first argument to each method is self. You know, we can declare other class methods like normal functions. However, it takes self as the parameter or the argument. Python adds self argument to the list for you, and you need not include it when you call the method. Here, although you are defining the methods with the self, and also init has first parameter as self, you need not uh, pass any argument in place of self. It is taken by the system, which is the object. Creating instance objects. How to create an object? To create instances of a class, uh, you call the class using class name and pass in whatever arguments init method accepts. What arguments our init method accepts? Our init method accepts name and salary. Therefore, here employee, and I have given example of creation of object here with respect to Java. Okay, with the syntax to create an object with respect to Java is class name, object name is equals to new class name. But in Python, it is not like that. What is the syntax? Syntax is object name is equals to class name within parentheses. If init is taking any argument, you specify that argument. If init does not take any argument, then don't pass any argument. Just place an empty parenthesis. And M2 is the second employee object that has been created. M1 dot display employee, M2 dot display employee, and print total employees. Uh, this is display employee is a function, and then with object you are calling it, and then it prints the employee one details, which are name and salary, Zara in 2000, and employee 2 employee dot display employee prints the details of employee 2, which are money and 5000. This is name and salary. Total employee count, how many employees have been created, that we are keeping track in our m count variable. Through that you can display it. Okay, that is individually it has been discussed earlier. Now they have combined it. We have a class from here till here. That is class definition, followed by object creation. First object creation, second object creation, invoking these methods and printing the count. So the output would be name Zara, salary 2000. This is for employee 1. For employee 2, name money, salary 5000. Total employees 2. Here object has got two members, two attributes, name and salary. Those attributes could be modified anytime, anywhere in the uh, program. So m1 dot salary equal to 7000. This is salary attribute has been modified now. Earlier it was 2000, now it is 7000. M1 name is also changed to XYZ. And here, please recall DEL. DEL statement is used to create uh, variables, objects, individual elements in a variable or in a list. So del m1 dot salary has now m1 dot salary has been deleted. Actually, this should be delete salary, and this should be modify name. That is typo H. And there are other functions. And these are the conventions to use these names: get attribute, has attribute, set attribute, del attribute. Uh, these are used to access attribute of an object. Get attribute means access the attribute of an object. You pass object name. You don't call it with object name, and rather you pass object as a argument. Please observe the difference here, students. This is how are you invoking display employee with object name, whereas there are other functions. Uh, these functions take object name as its argument and returns true or false. If salary is defined for employee 1, it returns true, otherwise false. Has attribute. It checks whether this employee has the attribute salary. Get attribute. Get attribute is whether this employee has uh, no, it's like getting the value for this attribute. This is determining whether attribute is there or not. This is getting the value for an attribute. Get value. Get attribute. Set attribute is to define a new value to the attribute. M1 salary 7000. This is defining new attribute to the object. Del attribute is to delete the attribute of this employee. Okay, these are some specialized functions which do not belong to our object. Rather, they take object as the argument, and then they work on the attributes of the objects. There are built-in class attributes, which are this dict. Dict is a dictionary containing class namespace. What do you mean by class namespace? All the names that are defined within the class, names of objects, names of variables, uh, functions. Doc is a class documentation string. If it is undefined, it contains none. If it is defined, will anyone tell me how do we define documentation string for the class? Please try, students, how to define a documentation string for the class. Here, when you are defining a class employee, whatever you are putting immediately after class header is a documentation string, which you enclose within single quotes, or you can use double quotes as well. Double quotes or single quotes, basically it is a string. It is called as a documentation string because it is immediately after class header. Yeah, very good, Sirisha. By using a string documentation, which is defined immediately after the class header. This is a class header. After class header, whatever follows is a documentation string, and this is optional. You may omit this. You may not want to have this. It's all right. It's totally fine if you don't define that. So that's an optional thing. Name would return the class name. Module is a module name in which class is defined. If so, whatever module is nothing but the name of the Python file. Please recall that we are storing the Python program in Python uh, file which has got an extension of .py, name.py, which is essentially a module. So this returns the module name. This built-in attribute module returns the module name. Bases, this is possibly an empty tuple containing the base class in the order of their occurrence. This is useful when we have inheritance, when a class inherits properties of another class. Class employee base class, this is a documentation string. This one is a class variable. These are this is an initialization function, and then this is a display function. This is also a display function, and then we have print statements that are printing all these built-in attributes of a class: doc, name, module, basis, dict. These are all the built-in class attributes which have been printed. We'll execute and look at the output. Uh, Objects, uh, you might have learned garbage collection in Java. Garbage collection is about releasing the space that has been allocated for the objects. Whenever objects uh, are no longer exist, Then when some space has been allocated, that space should be released in order to be reused. And garbage collection, Python deletes unneeded objects automatically. Like Java also have automatic garbage collect. This also deletes the uh, object memory automatically to free up the memory space. And this Python periodically reclaims. Reclaims means to get back blocks of memory that no longer are in use. And this is known as garbage collection. Python's garbage collector runs during program execution and is triggered when an object's reference count reaches 0. It maintains an object reference count. If an object is referenced and is being accessed, its count is say 1, 2, or 3 depending on the number of times it is accessed or referenced. When apparently the count reaches to 0, this happens when it is not being referenced. At that time, Python's garbage collector is triggered and it reclaims the memory space that was allocated to that particular object. So object's reference count increases when it is assigned a new name or placed in a container. When object reference count is increases, uh, first first way is when a new name has been assigned to it, or suppose if it is placed in any container. List tuple dictionary, they are called as containers or sequences because they contain number of elements. They don't have a single value, rather they have multiple values. Although you can create them with single values, but they are made up, they have been defined to be used for multiple values. And object's reference count decreases when it is deleted with del. If you say del and object name, it means that it has been deleted, and then its count is decreased to 0. And later Python automatically uh, um, uh, reclaims or revoke or get back the memory that has been allocated to it. Example is a equal to 40. This 40 object has been created and its reference is a. A is the reference to the object 40. B equal to a. Here reference count would increase. Why it would increase? Because a new name has been assigned to it. Guys, if you remember 40, this is stored in memory, and this memory is referenced by a name A. When we say B equal to A, now B is also referencing the same memory. When another statement says that C equal to B, actually C is a list and the list element is a B. Again, C is referencing uh, the same object 40. When we say del A, reference count is decreased by 1 because here we have 3, so then A is removed. It would be 2 now. A reference count is 2. When B equal to 100, when B is reassigned to a value 100, it loses this connection and a new memory is allocated to 100. Now B points to 100. Therefore, this reference count value is decreased by 1. Now it is just 1. When C of 0 is assigned to value -1, actually this B is the 0th value in the list which is referred by C. And later when we say C of 0, which in fact is 40. that you are changing to -1. So you are creating another memory object with the value -1 and now C points to it. Therefore, this connection is lost. And now the reference count is 0. When the reference count is 0, there is no need to have this 40 in this memory. So delete it and reclaim the memory so that it can be reused. There is a del destructor that prints the class name of an instance that is about to be destroyed. Within a class, there is a destructor with the name del underscore underscore del underscore underscore class name equal to self dot class dot name print class name destroyed. When destructor is invoked, that instance is destroyed. pt1 equal to point, pt2 equal to pt1, pt3 is equal to pt1. uh, id of all the three would be same now because all are referencing the same object. Del pt1 means first object is deleted, del pt2 second object is deleted, del pt3 third. Actually these are references. The third reference is also deleted, and all the references are deleted, which makes the count 0. And at that point, uh, destructor is triggered and it prints point destroyed. Okay, the next important thing is class inheritance. Class inheritance is about deriving the properties from an existing class. Instead of creating something from scratch, and if the part of it is already available, you need not create it again. You should reuse the thing which is available. For example, uh, in a house, if there is one water filter, let us take an example of water filter. This water filter could be shared by all the family members, and there is no need to uh, they buy a new water filter. But then this water filter perhaps uh, might be increased its quantity. You can increase the quantity of this by buying a new tank. Everything will remain same except the tank. So what is that? This is like an inheritance. Existing thing will remain as it is, something else will be added to it. That is inheritance. uh, the class which derives the properties of an existing class is called as a subclass, and from which properties are derived is known as a superclass. In this manner it is done: class subclass name within parentheses. The syntax here to define the superclass is that within parentheses you specify the parent class 1, parent class 2, and so on. And there is an optional class documentation string followed by class suit, which are the components of the class. Class parent, parent attribute equals to 100, initialization function, calling parent constructor. There is a method, parent method, calling parent method, set ADTR, defining the attribute, self ADTR, parent attribute is defined, assigned to ADTR, and def get ADTR, parent attribute is uh, printed here. And now there is a child class is inherit which is inherited from parent class and which derives the properties of parent class. There is a constructor function for or a initialization function for the child class, which is this is a child method printing just a function calling child method. Here creating an instance of child is equal to child. C dot child method, this calls this child method. C dot parent method, this calls parent method. C dot set attr, this is calling parent method to set the attribute. And C dot get attr, this is calling parents method to get the value. Observe here, students, parent method, set attr, get it. These three have been defined in parents class and not in the child class. And yet, child class could invoke them because child derives all the properties of the parent class. This is the output that we will see while execution. So class A, this is deriving from multiple parent classes. Class A is derived, uh, defined, class B is defined, class C is derived from A and B. This is the syntax. To do that, and then this this takes us to this, after that it takes us to this overriding methods concept. In this overriding methods concept, uh, when there is a method, my method within parent, same method could be overridden in the child class with the same name and with the same uh, header, same prototype. Prototype is same. Def, anyway the def is uh, mandatory. My method, self. Exactly a replica of parent method is defined here, and this is known as overriding method. When we call c dot my method, it calls overridden method, child method, and not the parent method. Base overloading methods, init, this is initialization method which can be overloaded. Del, like destructor. REPR, it is for evaluating string representation. STR for printing string representation. CMP for object comparison to find out whether both objects are similar or not. Overloading operators, this is to define an operator with a new meaning to it. Mm, Class vector, initialization method, AB, and str, this would print the object in the form of strings. That's why we have this str. Self dot a, self dot b. Not exactly objects, it's objects attributes. Objects attributes are printed here in str function, which returns a string having this message vector %d, which is a value and b value. Def add is another method which will return uh, this a plus whatever other value is there, that, and b plus others b. Self a means current objects a plus other object a, current object b plus other object b. V1 equal to vector of 2 comma 10. V1 is one object, V2 is another object. Now when we say print V1 plus V2, we are actually adding the objects. How is it possible? Because of this method, add method. Because of this add method, in add method, what are we specifying? We are specifying the attributes of the objects, and we are adding them. Directly you can invoke this v1 plus v2. Uh, if you don't have this add method and you try to say v1 plus v2, then it won't work because it Plus operator don't expect objects to be its operands. Plus objects require integers to be its operands. But here we are passing objects as operands. This is possible only because of this object operator overloaded method, which is a add. How to achieve data hiding? Defining attributes that may or may not be visible outside class definition. For that, you need to name attributes with a double underscore prefix. If you name, like in Java, you have private and attribute name. Here you don't have such keyword. Rather, you have to use double underscore as a prefix to the attribute name. Then it is not visible outside the class. It becomes a private member. So secret count, just counter, secret count equal to 1, count, secret count plus 1, self dot secret count. Here an object is created, counter equal to just counter, counter dot count, it will be 1, counter dot count, it will be 2. When you try to print the secret count value, it raises an error because it is a private member, it cannot be called outside the class. And it is saying that it does not have any attribute. Because it is private, it says that it does not have any attribute. All right, that's all about object-oriented programming with respect to Python. Let us quickly execute these programs. So I have to open this. There is no Jupyter notebook opened. So environments, AIP lab. This is one environment that I have created for your lab purpose. Open with Jupyter notebook. Select this option. Perhaps because many tabs are opened, it is not. Now I'll try. All right, students, do you have any doubts? With this, we have done with our Python. If you have any doubts, and also please don't restrict yourself to the classroom teaching learning. Uh, I mean, whatever I am teaching in the class, don't restrict yourself only to learn those concepts. Please expand your knowledge by learning that course, which is free. I already gave you that link in the first class. Uh, Go through that Python course and um, try to execute programs, try to trace the programs, try to understand the programs. Anyway, time has up now for our class. So I'll try to rectify the problem and show you the execution of all object-oriented programming programs tomorrow. And we will start tomorrow artificial intelligence theory as well, immediately after execution of the code. I'll start that. Uh, Students, please go through, and if you have any doubts, you please ask me. What are the questions that are left to be done? Hmm. So today you have to write this question number 20, up to 20, 27 are over, right, Manasa?
Yes, ma'am. Up to 27.
Today you complete 28, 29, 33. With that, only syllabus part will be completed. Again, I am reiterating so that you take it, uh, 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 serious and learn more about it, because Python is the state of the art, current technology. Everything, data science, machine learning, and uh, so many other domains are using Python only. Complete that free course which is available on the internet. Tomorrow we will begin with this artificial intelligence introduction. I'll see what is the problem, I'll rectify, and we'll have it tomorrow at 9 o'clock. All right, students, then.